The last format of a linear function, yep.
What is our unit test for this?
Wednesday next week. Yeah, good question. The last format for the linear equation is something called the general form. And this is one form that is most detached from the graph. Often when we are trying to graph from general form, we actually have to do something else first. And we'll see that a little bit today, okay? The general form looks like this. AX plus BY plus C equals 0, okay? And there are some conditions around this as well, okay? So firstly, A, B, and C are numbers. So just like all the other formats, the only two variables are X and Y. Okay, so some notes about this form. And not only are they numbers, but they actually have to be integers, which means we cannot have fractions or decimals, okay? So like, for example, if A was 1/4, we would have to do some work to deal with the fact that the coefficient is a fraction, okay? They have to be integers. Okay, no fractions or decimals. Okay, so that's one thing. I should put a little bullet point there or something. The other thing that's important is the A value, which is the coefficient of X, and A specifically has to be positive. Okay, so that's the second thing. Another thing that we can see from the format is that one side of the equation equals 0. Okay, so that's another just formatting thing to note. And then finally, and actually I made this mistake in the last period, the order of the terms should go X term, Y term, constant. Okay, so we kind of have to stick to this format. When I talk about general form, a lot of people sort of ask or think like, why are we doing this? This seems totally out there and it's not related to the graph. And I can totally understand that perspective and appreciate why it seems like we are making more work for ourselves. The reason that we start looking at general form, and in fact, you can see down here, I've got the 3 forms of a line in a box. There's another form that's related to general called standard form, where you have, the only difference is that one side is not 0, the one side is equal to the constant, is for a couple of reasons. And I would say the biggest one is what we're going to start to look at in our next unit, which is systems of linear equations, which is where you're managing several linear equations at once. This unit actually leads into a branch of math called linear algebra. And when we are looking at that branch of math, typically we're managing multiple equations and multiple variables all at once. So you may have X, Y, Z. You may have A, B, C, D. There may be 4 variables or 5 variables and 4, 5, 6 equations at once. And typically when we're working with that, we actually use something called a matrix to manage all of that information. But this is just barely the introduction to that, what we're going to do next unit, which is when we're actually going to look at 2 equations at once. And these formats are really nice when you're dealing with that type of mathematics, okay? Linear algebra is really not something, though, that you will visit again until university. If you take math in university, you'll start to look at matrices and that sort of thing. And I actually quite enjoyed it. It's not for everyone, but I thought it was pretty fun. It's, yeah, so that's kind of why we're getting into this now. It's sort of going to be some pre-knowledge for what's going to come next. Did you have a question?
What happens if you follow general form, but it has just linear terms? Do you just reorganize it?
Yeah, so that, exactly. So if something is in standard form or even one of the other forms and we want it to be in general form, yeah, we have to rearrange, right? And so that's a lot of what we're actually going to talk about today. Okay? And that's our first example. So write each of these equations in general form. Actually, before I say that, you have an example right here of something in slope-intercept form, something in slope-point form, and something in general form. These are actually all the exact same line. Okay? So any line can be written in all three forms. And yeah, one of the skills we want to look at today is how do we go back and forth. Okay? So we are going to do a couple of examples together. We'll talk about how to graph from general form, that sort of thing. We'll look at some applications. When we are trying to convert to general form, one thing that you want to consider is all of these notes that we talked about at the beginning, right? So A, B, and C have to be integers. So if you see any fractions, we have to deal with that, okay? Also, the coefficient of x has to be positive. Also, one side has to be 0, okay? So we're going to kind of work towards that and manage each of those things one at a time. There's multiple ways to do this. Personally, if I see a fraction or a decimal, I like to deal with that first. So here, for example, the coefficient of x is -2/3, okay? Which basically means I'm taking x, multiplying it by -2, and then dividing by 3. Okay, so to undo that division by 3, I have to do the opposite, which is to multiply by 3. So I'm going to start out by multiplying this entire equation by 3. And some people like to multiply the 3 by each term. Some people like to multiply on both sides. You can do that too. I kind of almost treat this like an expansion. And so if I multiply the whole thing by 3, then when I distribute, on the left side, I'm going to have 3y equals. When I multiply by 3 here, the 3's cancel. And that was the purpose of me doing this, right? So when the 3's cancel, all I'm left with is the -2x. Okay? And then 3 times 4, finally, is plus 12. Okay, so I have dealt with the fact that I have a fraction. Yep.
So when you multiply it by 3, it doesn't affect the numerator on the slope. It would be 3 times -2.
So, okay, that's a good question. When you're doing 3 times -2/3, right? So when you're multiplying fractions, you can actually do it two ways. You can multiply numerators and multiply denominators and then reduce. So that would look like this. 3 times -2 is -6/3, which is -2. Or you can actually reduce first if you see the exact same factor in the numerator and denominator. So these just cancel, and you're left with -2. Right? Now, when I'm using opposite operations, though, I know that the purpose of me doing this was for these to cancel. So I just write the -2 out. Yeah, but if you wanted to take that extra step and write it as -6/3, that's fine too. Okay? All right, what else do I have to deal with here? Yeah, so a couple things. One side has to be 0, and I have to ensure that the coefficient of x is positive. Okay? When I am deciding which side to make 0, because I could make the left side 0 or the right side 0, it doesn't really matter. I keep in mind the fact that I want the coefficient of x to be positive, right? If it's negative on this side, then if I move these two terms to this side, the coefficient of x will become positive. If it was already positive, I would leave it where it is and move the y term over, okay? Because then I can kind of kill two birds with one stone. Right? In this case, this is negative on the right side. So I'm going to add 2x to both sides and subtract 12, make the right side negative. Okay? Because now I also have a positive coefficient of x. So this is 2x plus 3y minus 12 equals 0. and that is now in general form. Okay? Any questions with that so far? No? Okay. Actually, let's do C next, because C is actually fairly straightforward. What do we have to deal with C? What has to be done? We have to remember one side has to be 0, no fractions, coefficient of x has to be positive. Yep. Yeah, one side just has to be 0, exactly. There are no fractions, okay? Now, what would you move to which side in this case? Yeah. Yeah, I would move the y because this 3 is the coefficient of x. That's already positive. So if I just subtract y from both sides, right? This becomes, I'm kind of wrote over here, so maybe I'll do this down here. On the left side, y minus y is 0. On the right side, I have 3x minus y minus 5. And that's done all in one step. Okay. Now let's look at B. What do we have to do first for B? Yeah. Yeah, you could distribute, sure. We could do that. So if we distribute, we're going to get y minus 1 equals 3 over 5x, and then this is like 2 over 1, plus 6 over 5. Okay, and then what would you do? Yeah, we could deal with the fraction at this point, right? So to deal with this fraction, denominator's 5. We're dividing by 5. What's the opposite of that? Multiplying by 5. So I'm going to multiply the entire thing by 5 and distribute that multiplication in. Okay, so when I go 5 times y, I have 5y. 5 times 1 is 5, so minus 5 equals, what happens here? The 5's cancel. So what am I left with? 3x, exactly. And then what about here? 5's cancel, so I just have 6. Okay. All right. What next? What else do I have to do? Yeah, I got to make one side 0. Okay. Which side would you choose to make 0? Yeah, this side, because this is already positive, right? So I'll just subtract 5y, add 5, subtract 5y, add 5. I try to do those kind of in the order that the terms should be, because sometimes I forget and I mix them up. 3x and then minus 5y plus 11. And now it's in general form. Okay. By the way, I just want to mention, if you happen to do it the other way, right? Let's say I decided to make the right side 0. And this is just an aside. You don't have to write this down. What you would end up with is this would be negative 3x plus 5y. And then you'd have to subtract 6. So minus 11 equals 0. Okay? So sometimes people do this and they're like, oh, no, now I have to move everything over to the other side. You could, but another really easy workaround is just to multiply both sides by negative 1. Because when you multiply 0 by negative 1, it's still 0. So that side's still good. And then when you multiply this by negative 1, all of these signs are going to change. Okay? So that's just a really sort of quick, easy fix that you can use if you happen to make the side 0 where x is negative. Okay? All right, so I'm going to get you guys to try a couple of these. Okay, so here is an equation that is in general form, and we are being asked to determine the slope of the line with this equation. Okay, so if something's in general form and we want to know the slope, how could we do that? Yeah. Yeah, convert, right? Exactly. If we convert this to slope y-intercept form, then we'll know the slope. Right? So now we're kind of going in the opposite direction, okay? Determining the slope, or converting rather to slope-intercept form, involves isolating y, okay? So here we can convert to y equals mx plus b, which means that y has to be isolated. Okay, so if I start with this equation, 3x minus 2y minus 16 equals 0, I need y by itself. So I need to start by isolating this term. I can either move these two over to the right, or I could just add 2y to both sides, right? And I usually just do that. Okay, so I end up with, 2y, there we go. 3x minus 16 equals 2y, and then I just divide everything by 2. Okay, and this cancels. And if you can simplify here, you should do so. So the slope here I can't simplify. It's just 3 over 2x, but negative 16 divided by 2 is minus 8. Okay, and then we actually know what the y-intercept is as well.
So then if you switch it around to y equals 3 over 2x, would it still be minus 8?
Yep.
That 8 is-
Yep, because like in an equation, because the two sides are equal, you can swap sides of the equal sign and they'll still be equal to one another. So you could write this as y equals 3 over 2x minus 8. If you want to swap, that's fine. I'm going to skip this one because we're going to do something similar on the next side, which is graphing from this form. Yep.
I'm just confused on how everything can fraction over 2.
How did everything, because over here? Oh, because this was 2y. So this implies multiplication. To undo that, I need to divide. So I need to divide the whole thing by 2. Does that make sense? Yeah, okay. All right, so we need to now graph this line, okay? Now, there's a couple of options when you are graphing from general form, or a couple of different methods that you could use. What do you think one of them is? Yep. Exactly. Yeah, convert to slope-intercept form. And then we know how to graph from that, right? So that's one option. And in fact, if you want to use technology, you have to do it this way. If you want to graph this on your calculator, you have to isolate y. Because if you notice on your calculator when you go to graph, everything says y equals, right? Y is always isolated. So we could do that. I'm going to do that over here because I know I'm going to run out of space here. 3x minus 2y plus 2y minus 18 equals 0. So I need to isolate y, so I will maybe subtract 2y from both sides. And I have 3x minus 18 equals negative 2y. And now I have to divide by negative 2. Okay, so this cancels. And what I end up with is over here, 3 over negative 2, or negative 3 over 2, whichever way you want to see it. X, here's my slope. And then negative 18 divided by negative 2 is positive 9. Plus 9 equals y, right? And if you wanted to switch these around so that the y was on the left side, that's fine too. This is in slope-intercept form. How do we graph from slope-intercept form? Okay, well, rise over run is part of it. Where do we start? Y-intercept, yeah. So that's at 9. And then my slope is negative 3 over 2. So I'm going down 3, right 2. 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 And here is my line. Okay, so that's one option. And I would say that this is the one that most people use, especially when you're in grade 10, because we're just really used to graphing from this form. What I personally do when something's in general form is I actually use the intercept method. And that actually comes back to our last unit. And what that relies on is that when you are at an intercept, you know one of the two coordinates, right? So if you're on the y-axis, the y-intercept, x is 0. And if you're on the x-axis, y is 0. And if you can even just plot those 2 points, you connect them, you've got your line. Okay? The reason why I like this strategy is because I can actually figure them out usually in my head. Not always, but often. And I'll show you what I mean by that. If we're at the y-intercept, x is 0. So if I look at this equation, if x is 0, this term disappears because 3 times 0 is 0. So what I'm left with is 2y minus 18 equals 0. Okay? I can solve this in my head, and I would bet that a lot of you can as well, right? You're thinking 2 times something minus 18 has to equal 0. What does that something have to be? 9, right? Because this part, 2y, has to equal 18. So you have 18 minus 18 equals 0, right? Of course, if you can't figure it out in your head, just use opposite operations. Add 18 to both sides, and we end up with 2y equals 18. Divide by 2, y is 9, okay? And then I'm going to plot that point. There's my y-intercept. Okay, and then to do the x-intercept, y is 0. So now this term goes away, right? Because 2 times 0 is 0. So my equation becomes 3x minus 18 equals 0. And this is also something that I can solve in my head. 3 times something minus 18 has to be 0. What does that something have to be? 3 times, this piece has to be 18. 3x has to be 18 because 18 minus 18 is 0. So 3 times what is 18? 6, right? Now, of course, again, you could add 18 to both sides. That's essentially what we're doing in our heads. We got x equals 6. So then I go and I plot that point, right? And then I just connect them, and I've got my graph. Okay? Questions with that? Oh, verifying. The verifying is also in here. Okay, so verify that the graph is correct. So when we're verifying, we've spoken about this before. There's a couple of bad choices for points. What do you think those are in this case? Y-intercept and x-intercept, yeah. So pick something that's not one of those because those can give you false positives, okay? So I'm going to maybe pick this point here. This is the point 2, 6. Okay? Now the other thing that you want to keep in mind when you're verifying is if you have converted to slope-intercept form, verify in the original equation. Do not verify in slope-intercept form, because if that's where your mistake is, and you verify in that equation, you're not going to catch it, right? So when you're verifying, the equation was 3x plus 2y minus 18 equals 0. I'm going to use the point 2, 6. Okay? And so all I'm going to do is plug that in for x and y and see if the left side equals the right side. Right side is 0. Okay? Left side is going to be 3 times 2 plus 2 times 6 minus 18. Okay? And then that's 3 times 2 is 6 plus 2 times 6 is 12 minus 18. 6 plus 12 is 18. 18 minus 18 is 0. Okay. Any questions with that? No? Okay. So I would like you guys to try this one. And then we're going to talk about 1 or 2 applications, and then we'll be done. Yep. There you go. Yep. Here's an application question. Peanuts cost $2 per 100 grams. Shh. Thank you. And raisins cost $1 per 100 grams. So this is probably like from a bulk bin, that sort of thing. Devin has $10 to purchase these items. $10 to purchase both these items. Okay? First thing we're asked to do is to generate some data for this relation. Okay? So what do you think the variables are? What do you think the unknowns are? The cost. Well, we know that Devin is spending $10.
How many?
Yeah, how much of each, right? So when you're generating some data, a really valuable thing to do is say, what are my two variables? My variables are how much peanuts I buy and how much raisins I buy, okay? So I like to do that as a let statement, okay? Let the amount of peanuts be P, or I should actually probably use the word mass, not amount, but mass. And let the mass of raisins be R. Okay, and then I am sort of constrained by the fact that Devin can only spend $10. So if I'm creating a table of values with P and R, okay, the peanuts are $2 for 100 grams, and the raisins are $1 for 100 grams. Okay, so they cost different amounts. Let's say I don't buy any peanuts and I buy all raisins. I buy 0 grams of peanuts. And I have $10 to spend on raisins. What's the mass of the raisins that I can buy? Yep, 1,000, yeah, totally 1,000 grams, because I have $10 to spend and they're $1 per 100 grams. So I can go 100 times 10, that's 1,000 grams, right? And what I kind of like to do is say, okay, how much would I be spending on peanuts? 0. Then I'd be spending $10 on raisins. Okay? What if I bought 100 grams of peanuts? How much would that cost me? $2. Okay. How much would I have left to spend on raisins? Right, $8. Okay. How many grams of raisins can I buy with $8? 800. That's right. Okay. What if I bought 200 grams of peanuts? How much would I spend on the peanuts? $4. How much would I have to spend on the raisins? $6. Okay. How many grams of raisins can I buy with that? 600 grams. Okay. And there's a pattern that's going on here, right? So these values, how much are these going up by? 100. So the next one's going to be 300. What would this be?
400.
Yeah, because these are going down by 200. 400 grams. And if this was 400 grams, this would be 200 grams, right? And if this was 500 grams, what would this be? 0 grams. Yeah, and that's sort of my extremes, right? I can either buy all peanuts or all raisins rather, or all peanuts, or some combination of each. Okay? So this, of course, is not all of the data, because with like a bulk bin, you don't have to buy exactly 100 grams. You can buy part of 100 grams. But these are just a few data points. Okay, so that's the first piece. Write an equation for this relation in general form. We talked a little bit about writing equations yesterday. And one thing that I mentioned is that this is something that you should only pay attention to at the very end. Get an equation in any format that you can. Then worry about converting to general form. Okay? Now we talked yesterday as well about the fact that when you're trying to get an equation, you need two things. You need a slope and either a y-intercept or a point. Okay? Well, in fact, we actually have a y-intercept here, because when p is 0, we know that r is 1,000. So we know that b is 1,000. How would we figure out the slope? What could we do? Yeah.
Figure out which is our vertical and horizontal axis, and then figure
Yep.
out what each one is like changing by.
Yeah. So we have several points. If you have 2 points, what can you use to get slope? Yeah, slope formula. Now, one thing about, you mentioned the horizontal and vertical axis, right? Oftentimes, one variable is clearly dependent and the other one is clearly independent. Is that the case here?
No.
No. So either one of them could be dependent or independent. Just pick one arbitrarily. It really doesn't matter. Okay? So just the way I've set it up, I'm going to say that P is independent and R is dependent. Okay? Because that's what my table of values looks like. So I could use any two data points. I could use 0, 1,000, and 100, 800, for example, to get my slope. And if I use those 2 points, I'll have y2 minus y1, 1,000 minus 800. Not 8,000, over 0 minus 100. Okay, and that is 200 over negative 100, which is negative 2. Okay, so this is my m value. So I got my b value, my y-intercept, my slope value. If I want to put this into an equation, right, typically it's y equals mx plus b. I'm using different variables though, right? Instead of y, I am using r, that's the raisins. So I'm going to put an r here. And then my m value is negative 2 times, instead of x, that's my peanuts, times p plus 1,000. Okay, now we can think about general form. So for general form, maybe this is negative, so I'll move it over to the other side and subtract 1,000 plus 2p minus 1,000. Right, so now the right side is 0 and the left side is 2p plus r minus 1,000 equals 0.
You wrote P twice.
Thank you. That's an easy fix. There we go. Okay. Now, if we look at the next couple of questions, will Devin spend exactly $10 if she buys 300 grams of peanuts and 400 grams of raisins? We sort of already generated that data in our chart, right? So 300 grams of peanuts, 400 grams of raisins. Yep, that works out. What about if she buys 400 grams of peanuts and 300 grams of raisins?
She doesn't have enough money.
Yeah, that would cost more than $10 because this part would be $8 and then the 300 grams of raisins would be another $3. Okay? And you could also use the equation to verify, right? If you plug in P equals 400 and R equals 300, then you'll see that the left side doesn't equal the right side. Okay? And then, of course, you could graph this. I'm not going to do that right now because we're about to run out of time. But I'm going to pause everything here and get you guys to write your quiz in the last part of class. This is pretty much the end of this unit, though. Okay?